Why plastic recycling is failing, how science can fix it. Rethinking plastic recycling, a call for change. Plastic recycling is not merely hindered by consumer behavior. It is also constrained by fundamental thermodynamic, chemical, and engineering challenges. Updated July 28, 2025, 014 p.m. EST. A new perspective on plastic. From innovative polymer designs to advanced sorting technologies, the engineering community is actively reimagining the future of plastic. Waste and our role in it. Waste is not a modern phenomenon, nor is humanity's contribution to it. Since industrialization began, our capacity to generate pollution has grown in tandem with our technological advancements. In 1862, British inventor Alexander Parkes introduced Parkesine, the first synthetic plastic. Little did he know that this semi-synthetic thermoplastic, derived from cellulose treated with nitric acid and a solvent, would ignite a material science revolution. This cellulose-based innovation opened the door to a plethora of new materials. Captivated by the adaptability and resilience of plastic, inventors rapidly began to enhance and proliferate it, leading to the creation of materials like celluloid, bakelite, PVC, nylon, and PET, which soon became ubiquitous in daily life. The early signs of a persistent pollutant. By the late 1960s, the repercussions of plastic usage started to emerge. During plankton studies in the Sargasso Sea, scientists Edward J. Carpenter and K. L. Smith, Jr., from the Woods Hole Oceanographic Institution, discovered numerous tiny plastic particles intermingled with seaweed. This discovery highlighted that plastic pollution was not a minor issue, but a growing menace. In response, engineers turned to recycling, a waste management strategy aimed at converting plastic into reusable raw materials for new, valuable products. Initially, recycling appeared to be a clever solution, effectively reducing waste, conserving resources, and preventing a significant amount of plastic from entering the oceans. However, as time passed, the limitations of this approach became apparent. Recycling is not only expensive and sometimes inefficient, but it also raises serious concerns regarding toxicity and environmental pollution. Recycled plastics often harbor harmful chemicals and can release microplastics back into the ecosystem. This begs the critical question: is recycling still the best strategy to tackle the global plastic crisis, or is it time to innovate and develop superior solutions? Understanding plastic recovery. Recyclable materials can be processed through mechanical, chemical, or energy recycling, all of which share three fundamental steps: collecting waste, sorting recyclables, and converting the remaining materials back into raw resources. Mechanical recycling is the most prevalent method for processing plastics, like polyethylene terephthalate, PET, and high-density polyethylene, HDPE. This process typically involves collection, sorting, washing, drying, grinding, and finally compounding and pelletizing. To date, it remains the only form of plastic recycling widely practiced on a commercial scale. On the other hand, chemical recycling is a relatively novel technology that seeks to restore plastics from any level of degradation back to their original, high-quality raw materials. This method is particularly useful for hard-to-recycle plastics, such as snack bags and ready meal trays, which mechanical recycling struggles to handle efficiently. Chemical recycling can be achieved through various processes, including pyrolysis, where polymers are heated in the absence of oxygen and broken down into smaller components resembling oil. Gasification, which involves heating polymers with oxygen and water to produce a gas mixture. Hydrocracking, where large plastic molecules are reduced to smaller ones using hydrogen. And depolymerization, which breaks down polymers into monomers, yielding raw materials directly usable for new plastic production. Energy recycling, in contrast, entails burning plastic to generate heat, which can then be converted into electricity or heating. While this method utilizes the energy content of plastic, it does not recover the material itself. Analyzing the costs. Despite its widespread use, mechanical recycling is not without its costs. Operating expenses typically range from $50 to $200 per ton, meaning that recycling the 460 million metric tons of plastic produced annually could potentially cost up to $192 billion, if feasible at all. Many plastics are unsuitable for mechanical recycling due to contamination or material limitations. Chemical recycling, however, incurs even higher costs, ranging from $300 to $1,000 per ton. This technology is still in its infancy and is currently limited to demonstration plants and smaller facilities. While data on energy recycling is scarce, estimates suggest that energy consumption across all plastic recycling methods accounts for about 1/3 of total operating costs. Nevertheless, recycling offers substantial environmental advantages. For instance, recycling a single ton of plastic can conserve up to 5,774 kilowatt-hours of energy, save 16.3 barrels of oil, and free up 30 cubic yards of landfill space. Compared to producing virgin plastic, recycling can reduce energy consumption by over 80%. The hidden dangers of recycled polymers. While recycling can extend the life of plastic, it does not eliminate the harmful chemicals that may be present in plastic waste. Certain substances can leach out or persist throughout the recycling process, ultimately contaminating the recycled material. A 2023 report from Greenpeace indicates that recycled plastics frequently contain elevated levels of hazardous substances, including flame retardants, carcinogens, and hormone-disrupting chemicals, as well as persistent environmental pollutants like brominated and chlorinated dioxins. Moreover, chemical recycling methods such as pyrolysis can release pollutants like mercury, arsenic, formaldehyde, carbon monoxide, nitrogen oxides, and sulfur dioxide, contributing to air and water pollution. Mechanical recycling can also produce new toxins when plastics are heated. Even minor contamination, such as PVC and PET, can generate benzene, a known human carcinogen associated with leukemia and other severe health issues. A recent study conducted by researchers from the University of Gothenburg and Leipzig found that a single recycled plastic pellet can contain over 80 different chemicals. We identified common plastic chemicals, including UV stabilizers and plasticizers, as well as substances not typically used as plastic additives, such as pesticides, pharmaceuticals, and biocides, stated Eric Carmona, a researcher at the Department of Exposure Science, Helmholtz Center for Environmental Research in Leipzig. Designing for end of life, not just performance. As the world moves beyond traditional plastic recycling, many companies are investigating innovative alternatives, such as mushroom-based packaging and advanced biopolymers, which promise to be more environmentally friendly than conventional plastics. Recycled cardboard and paper continue to be the most commonly used biodegradable substitutes for plastic packaging. However, experts argue that the true solution lies in reducing our reliance on plastic and rethinking the entire system. Researchers and policymakers alike emphasize that achieving sustainable change requires more than merely altering materials. They assert that plastic recycling cannot be deemed safe unless all hazardous chemicals are entirely eliminated from the process. Elsa Olivetti, Ph.D., a materials science and engineering professor at MIT, stresses the importance of clear regulations and standards for scaling recycling efforts. To be effective, policies must not only focus on increasing recycling rates, but also consider the entire supply and demand cycle and the various stakeholders involved. Olivetti remarked, "We cannot safely produce and utilize recycled plastics if we cannot trace chemicals throughout the production, usage, and waste phases," added Bethany Carney-Almroth, Ph.D., a professor at the University of Gothenburg. Until we address these challenges, even the most groundbreaking recycling processes will remain limited by the very chemistry that made plastic such a remarkable yet durable material in the first place. Fighting plastic pollution at source. Recycling might seem hip, but how about we really tackle the root of plastic pollution? The alarming reality is that global plastic production is skyrocketing. According to the Organization for Economic Cooperation and Development, OECD, in 2021 alone, the world generated over 400 million tons of plastic. This figure is shocking, representing a doubling of plastic production since the early 2000s. If we continue on this current trajectory, experts predict that plastic consumption could triple by the year 2060. However, here's the twist. Our recycling efforts aren't keeping up with this massive increase. Data from the OECD reveals that only about 9% of plastic waste is successfully recycled, while 19% is burned in incinerators, leaving a staggering nearly 75% to either end up in landfills or be carelessly discarded into our natural environment. Plastic waste is everywhere, yet it often goes unseen. Depending on its type, plastic can take anywhere between 20 to 500 years to break down, and even then, it doesn't completely vanish. As plastics degrade, they fragment into minuscule pieces known as microplastics, which are less than 5 millimeters in size. These tiny remnants are infiltrating our oceans, soil, and waterways, and they can even be found in living organisms, including fish and, alarmingly, in human bodies. Research has detected these microplastics in drinking water, breast milk, and even human blood. The implications for human health are a growing concern and have sparked many scientific studies highlighted in the media. The European Union is stepping up to address this crisis. In an effort to combat the overwhelming tide of plastic waste, the EU has enacted a series of transformative measures. First, single-use plastics ban. As of 2021, the EU has prohibited certain commonly used single-use items, such as plastic bags, straws, and cutlery, designed to be easily replaceable with more sustainable alternatives. New packaging laws. The EU's updated regulations aim to cut down on excessive packaging while enhancing the recyclability of materials used. Microplastics regulations. The addition of microplastics in certain products like cosmetics and detergents is now limited through the European REACH regulation to mitigate harm. Maritime safety initiatives. A proposed regulation intends to curb the loss of industrial plastic pellets at sea, thus tackling microplastic pollution. A Marine Strategy Framework Directive. This directive, which focuses on safeguarding marine ecosystems from debris, is currently undergoing revisions to better serve its purpose. Additionally, the EU is investing in numerous research initiatives aimed at creating bio-based and biodegradable alternatives to conventional plastics. Projects such as Sea Live in Valencia and R3PAC are at the forefront of this effort, demonstrating a commitment to innovation. Brussels is setting the ambitious goal of ensuring that all packaging on the market is either reusable or recyclable by 2030, significantly enhancing economic efficiency in reuse systems. Looking beyond its own borders, the EU is advocating for a global treaty on plastic pollution. This draft treaty has been under discussion since 2025, and reports indicate a divide in perspectives emerging. On one side, a high-ambition coalition that includes over 100 members, such as the EU, Rwanda, Norway, and Peru, is advocating for a legally binding agreement that covers the entire life cycle of plastics, incorporating both upstream and downstream measures. Conversely, some nations, especially major oil-producing countries, prefer an agreement that primarily addresses downstream issues, focusing on waste management and recycling. The more contentious upstream measures bring up several crucial topics, including sustainable production and consumption of plastic, tackling the challenges posed by problematic items like single-use plastics, and reducing the use of dangerous chemicals. As we ponder the future of plastic waste management, the next negotiation session will occur in Geneva from August 5th to 14th, 2025. What's your take? Should we emphasize recycling, or is it time to focus on reducing plastic use at its source? Let me know your thoughts in the comments. The dark truth about plastic recycling. What happens to your plastic bags? Experts uncover the truth about plastic bag recycling. A shocking revelation. An in-depth investigation into the plastic recycling systems in the United States has exposed a troubling reality. The authorities may be misleading the public about the effectiveness of recycling efforts. Plastic pollution is a significant contributor to the deterioration of our planet's natural resources. These materials not only harm ecosystems, but also pose serious risks to human health. The fact that plastic is non-biodegradable means its effects linger in the environment for generations. Despite being aware of the severe consequences of plastic waste, governments and organizations appear to be falling short in their recycling initiatives. The American Chemistry Council, ACC, launched a recycling program aimed at encouraging the public to recycle plastic bags, which are a major source of plastic waste. However, when ABC News conducted a covert investigation using tracking devices on plastic bags to assess the recycling process, the unsettling truth came to light. Investigation raises questions about plastic recycling. With the growing concern over the rising tide of plastic waste, particularly from retail sources, the ACC, a trade association representing plastic manufacturers, implemented the RAT program. This initiative established 18,000 drop-off points across the country, primarily located at Target and Walmart stores, where consumers could deposit their plastic bags. Retailers were tasked with the responsibility of collecting these bags. Joshua Baca, the vice president of the ACC's plastic division, stated, "We want to make it easy, simple, and convenient for consumers so that they can do the right thing that they want to do, which is recycle more products." To evaluate the program's success, ABC News deployed 46 tracking devices across 10 states in the U.S. as part of their largest investigation into the recycling of plastic bags. By closely monitoring the trackers, the news organization was able to determine the fate of most plastic bags collected at these drop-off locations. Alarmingly, the majority of the trackers were found far from their intended recycling destinations. A small number ended up in landfills, such as the Seneca Meadows landfill in Waterloo, or were incinerated. Surprisingly, many trackers were discovered thousands of miles away in countries like Indonesia and Malaysia. The harsh reality of plastic recycling. Judith Enck, the president of Beyond Plastics and a former regional administrator for the EPA, remarked, "No responsible waste company in the United States, no responsible local government should be exporting plastic waste to other countries." The trackers made their way to these Asian nations through plastic imports, which accept waste from other countries. Unfortunately, only 4 out of the 46 trackers were last detected at facilities in the U.S. that were genuinely involved in recycling plastic bags. Baca acknowledged that the store drop-off program is not as effective as intended and emphasized the need for alternative solutions. A report from the Organization for Economic Cooperation and Development in 2018 revealed that less than 10% of plastic waste is actually recycled. This statistic highlights a paradox within the plastic recycling industry. Those who advocate for recycling often include the same wealthy stakeholders who resist meaningful change. Notably, Walmart and Target declined to participate in interviews with ABC News and prevented the investigation team from tracking the fate of the plastic bags dropped off at their stores. Portney Williams, a resident of Peekskill, New York, an area known for its pollution, suggested that consumers need to be educated about the implications of plastic recycling and its impact on the air quality they experience. Join the conversation. What do you think about the current state of plastic recycling? Are you surprised by the findings of this investigation? Share your thoughts in the comments below. More on green matters. Researchers tested rainwater collected from Rocky Mountains, left dumbfounded on finding microplastics. Conservationists spot sea turtle with unusual horn in its nose, stunned on knowing it was single-use plastic. Sweet Border Collie helps its owners tidy up the streets by picking up over 1,000 plastic bottles.